So now we are doing the division of the terms having exponent. For division, you have to recall the negative exponents, which we have just studied. Negative exponents. So what we studied there, that if x raised to the power minus 2, we can bring this to the denominator by changing the sign of the exponent. And similarly, if x raised to the power minus 2 is in the denominator, so we can bring this to the numerator by changing the sign of the exponent. Simple. So now when we are dividing two terms having the same base, for example, take an example, it will be easier. X raised to the power 5 divided by x raised to the power 3. So how we solve this problem? Well, we just bring this term to the numerator. So we say x5, and when we bring this term to the numerator, the sign of the exponent will change. So x raised to the power minus 3. Now it's a multiplication. So we convert this division into multiplication by changing the sign of the exponent. And now we simply multiply. So what would be the answer? For multiplication, we just add the exponents. So by adding 5 plus minus 3, which is equal to x raised to the power 5 minus 3, which is equal to x square. So x square would be the answer. So when we divide two terms which have exponents, we simply bring the denominator to the numerator and change the sign. In other words, we can now formulate this. To generalize this thing, we say, okay, if x raised to the power n is divided by x raised to the power m, any other exponent, could be same, but so this will be equal to x raised to the power n minus m. So the exponents of the numerator, exponent of the denominator will be subtracted from the exponent of the numerator. So this is just opposite to the multiplication. In multiplication, we add the exponents. In division, we subtract the exponents. And this is how we prove this, that actually if we bring this exponent to the numerator, the sign will change, as we have already discussed in negative exponents. That negative exponents can be converted to positive exponents by bringing from numerator to denominator or denominator to numerator. So we have not derived, but just explained this formula that x, if the two terms are being divided, the resultant would be the difference of the exponent, exponent of the numerator minus the denominator, and the base will stay the same. So this is the way we do the division of the terms with exponents. And now once again we visit why x raised to the power 0 or any number raised to the power 0 is always 1, except the 0, which we have discussed earlier. So why it is so? To explain this, we can write x raised to the power 0 equals x raised to the power 1 minus 1. We can write 0 as 1 minus 1 or 2 minus 2 or 3 minus 3, any number. So I just put 1 minus 1. So now you can see that two exponents are added together. So it means I can write this in a multiplication form, the x raised to the power 1 multiplied by x raised to the power minus 1. Because this is what we do. If two terms are being multiplied, we add their exponents. Now I am doing the reverse. I have a term in which two exponents are being added, and I am converting this to two terms, x raised to the power 1 and x raised to the power minus 1. Now x raised to the power 1, I will keep it there, but using the negative exponent, I will take this x minus 1 to the denominator and make it positive. Because whenever a term goes from numerator to denominator, the sign of the exponent changes. So the minus 1 will become plus 1 in the denominator. And you can see what is going on here. You can simply cancel these two terms out. And this cancellation will result in 1, not 0, as explained earlier. That when you cancel these two terms in numerator and denominator, you are left with 1, not with 0. So therefore, this equals 1. So it means x raised to the power 0 is 1, because we are actually dividing x with x. So it's very simple to explain.